All right, this is the Big Ideas Geometry, section 10.5, angle relationships in circles. So we're going to talk about how to find angle and arc measures and use circumscribed angles. So if a tangent, which is a line that connects a circle but only goes through one point, like this line A is a tangent, if a tangent and a chord intersect at one point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So we're going to look at, you have this tangent of line A, and you have chord AB that are meeting at this point A. You're creating two different angles on both sides of this chord. There are arcs that are intersecting this, and both of those arcs total to equal 360 degrees. But similar to how we were looking at inscribed angles with a circle, the arc measure divided by 2 gets you the inscribed angle. So you can look at this with a couple of examples. We've got tangent M intersecting chord AB on this circle to form this inscribed angle 1 and the arc measure of 130. All we're going to do is take that arc measure, cut it in half, or divide by 2 to get 65 degrees. Same thing going from in to out, it's just the opposite. So you have for part B, tangent M and chord KL, and you're given that the in angle is 125. To get the arc measure on the outside, you do the opposite, which is times 2 to get 250 degrees for the arc measure. Now, for lines that intersect in the circle, if two non-parallel lines meet inside the circle, there are 3 different places where those lines could possibly go. One of them is on the circle, one of them is in the circle, and one of them is outside the circle. So there's different relationships that could happen between those angle measures and the lines, depending on where those two lines meet up. So if those two chords meet inside the circle, like this diagram shows right here, then the measure of each angle is 1/2 the sum of the arcs that are intercepted by its vertical angles. So that sounds kind of wordy and it's a lot. Let's look at just angle 1 in this diagram. So angle 1 has vertical angles, the ones that are, remember, across from each other. So this red arc and the blue arc, think of those as vertical arcs, or they're the corresponding intercepted arcs. If you take arc measure AB and arc measure DC, add them together, and then divide by 2, you will get the measure of angle 1, which is also, again, the same as this vertical angle, because remember, vertical angles are congruent. For number 2, the corresponding arc measures are BC and AD, because those are the ones that are touching it. So if you add whatever the measure of arc AD is and the measure of BC, cut it in half, you get the measure for in angle 2. Now, if they're intersecting on the outside, they could be tangents or secants, both tangents, both secants, wherever your lines are meeting on the outside, that is going to be 1/2 the difference or subtracting of its intercepted arcs. It's different from the last one because these two are meeting on the inside, so you add, but if those two lines meet on the outside, then you're going to subtract, and you always subtract traveling towards the point of intersection. So notice how BC is first and then AC, because you're going towards the point of intersection. So this angle 1 is meeting on the outside of this circle. You take the measure of arc BC minus the arc of AC, and then cut it in half to get your inner angle 1. Same thing right here. Take arc PQR, subtract arc PR, cut it in half, and you get your angle 2. Arc XY minus arc WZ, cut it in half, gets your angle 3. So let's look at these couple different examples. The first one is if the lines meet on the inside. The second one is if the lines meet on the outside. So we're going to find the measure of X, which is this interior angle in the circle where these two chords are meeting. You don't know if they're diameters, you just know that they're chords. You do have intercepted arcs that are measuring 156 and 130 on JM and KL. So what we're going to do, since this is meeting on the inside, we're going to add the two arcs together and then cut that measurement in half. So take 130 plus 156 to get, I don't know what that is, 286, and then you divide by 2 to get 143. Now, if it's on the outside, the only thing different you do is you're just going to subtract because the point of intersection is on the outside. So you take your bigger one or the furthest away arc, 178, minus 76, cut that in half to get your x. Subtract those and you get 102, and then cut in half, you get 51. So just pay attention to the difference of whether lines meet on the inside or the outside of that circle. Now, a circumscribed angle is one where the sides of that angle are tangents to the circle. Remember, tangents only meet at one point on the circle. If we look at this last example, this CD is a tangent because it meets once, but this CA is a secant because it's crossing twice. So if both are tangents, then it's considered to be a circumscribed angle. If you have a circumscribed angle, the measure of that is going to be equal to 180 minus the measure of the central angle of its same arcs. So the ADB is this angle measure right here. It's going to be equal to 180 minus the measure of the opposite angle. So notice how these tangent lines create perpendicular to the radius, 90 and 90, which means that the total is going to be equal to 180. So that's where that 180 comes from.